Hello, good morning. This is Nas from NB Network Lessons. Good morning to you, all of my followers, all of calculus lovers from Dallas, Texas. Thank you for joining. Today, the date is July 20th, 2024, and we're going to solve a problem of this function right here, and we're going to try to find directional derivative. In my last lecture, I introduced you with the concept of directional derivative. So if you need to refresh, please go back and take a look at the introduction to directional derivative. Okay. So basically, just to recap real quick, so far what we've been doing is that we've been finding derivative along x-axis, we've been finding derivative along y-axis and z-axis. Okay. Now, in real life, you have to find a directional derivative, rate of change of a function along any direction, not x, not y, not z, and that is what directional derivative is. So I've wrote this equation with respect to x and y, this long function right here, which could be any function along x and y, okay? And we just need to find a directional derivative in a given direction. So the initial point x0 is 1, y0 is 1. Unit vector for, not unit vector, but the vector for a1 is 1 over under root 2 I. a2 component of y, a1 is component of with respect to x, a2 is component with respect to y is also equal to 1 over under root of 2 j, and this sign right here symbolizes it's a vector. So first thing, anytime you want to find directional derivative, you need to make sure that the sum of the vectors x component and y component is 1. So let's go ahead and do that. So what we're going to do is we're going to verify if a is equal to a1 vector plus a2 vector is equal to 1. So a1 right here is 1 half I plus 1 over under root 2, sorry, I said half, it's under root 2, j, okay? We need to find what it is. So basically, a is going to be just this part right here, which is 1 over under root 2 plus a2, which is just this part right here, 1 over under root 2, which is equal to 1. So then the sum of x component vector and y component vector is 1. So it is a unit vector. So we can proceed with finding directional derivative. Okay. If it's not 1, we use math and calculus to make it 1. And I'll show you that in next example. So now what we got to do is we got to find out the partial derivative with respect to just x. So f subscript of x is equal to 2x raised to power 2 is going to be 4x minus 3y, and then y square I'm going to treat it as constant, 15 I'm going to treat it as constants. Now find subscript of y, take derivative, partial derivative with respect to just y. I'm going to treat this as a constant. All right, I'm going to take derivative of minus 3xy. I am going to get minus 3x plus 2y. 15 is a constant. So ladies and gentlemen, we got the derivative with respect to x. We got derivative with respect to y for this function. Now what we got to do is we got to apply that to the equation which I showed you, and I'm going to write that down again on the board. So directional derivative function at x0 is equal to 1, y0 is equal to 1 is going to be equal to f of x into 1 multiplied by a1 plus f of y 1 multiplied by a2. That's how you find the directional derivative. Okay. So now if you expand this, if you go ahead and solve this right here, function of x at point 1 and 1 what you do is that you plug in 1 for x, 1 for y. All right. So then I get 4 minus 3. Okay. Value of a1 right here, we are already given half 1 over under root 2. Okay. And then plus, what is function of y? Function of y is this, plug in x, initial x, which is 1 right here. So we get minus 3. Plug in y for 1, we get plus 2, multiplied by the y component of the vector, which is 1 over under root 2. Okay. If you solve this, if you open it up, you get 1 over under root 2 minus 1 over under root 2. And the answer is 0. Wow. So what does that mean? Answer is 0. What that means is that there was no rate of the change. Function is in this dA, directional function was constant, going constant, constant, constant. There was no rate of change. The rate of change is when you go like, maybe there is a rate of change going up, down, or it's going slow, going fast. So there was no rate of change. That is what derivative of 0 means. So thank you so much for watching. I will see you next time with another example. Take care of yourself. Have a good day.